All right, the title of this podcast is Population Counts, so please write that as a heading in your notebook. What we're going to be looking at in this is what are some ways that we can actually get a feel for how many organisms are out there. So it might be plants that we want to get a count of, it might be animals we want to get a count of, it might be fungi we want to get a count of. But in any case, there are different tools we can use to count those different organisms. And most of the tools are based around something called a census. Now, you have a census in the United States every 10 years to see how many people are living approximately in the United States, and they send out all these mail flyers and things like that for all the households to report, how many people are living in their household. Unfortunately, we can't do that with other organisms. We can't send mail to the deer population to figure out how many deer there are in Minnesota. So we have some other tools that we use to do that. So first of all, just what is a census? Census is going to be a population count. And as I said, there are different ways to do this. A true census is when you actually go out and count every single organism that lives in that area. Okay, so you manually count all organisms, and all is important. So we would have to go out, again, to get this deer census done. We would go and we would count every single deer in Minnesota. You can imagine how difficult that would be. Now, for some organisms, that's not very difficult. Maybe it's organisms that sit still and there aren't very many of them, like plant species and things like that. And we can do a true census for those. But one of the most common types of censuses that we use is called a sample census, which is down here. And that's where we do not count every single organism, but we have an estimate, okay, EST for estimate, of the population density. So we figure out in a certain area approximately how many organisms are living. And I'm going to give you a little bit more of an idea of what this means here in a second. All right, so when we're setting up a sample census, what will happen is we'll mark a plot of a typical habitat. So we'll go into that maybe forested area where those deer are living, and we'll plot out an area. Oops, back up. My mistake. Okay. So again, we're going to go back to that forested area and we're going to plot out a circle or a rectangle or a square within that area that we're actually going to focus in on. And the important part of this area is that it's a typical habitat. So if the majority of the habitat doesn't have much access to water, we don't want to pick out a habitat that has a lake right smack in the middle of it. Right? That wouldn't be the typical habitat for the larger area. So we want to try to find a habitat that's as representative of the whole as we can, and then make that our plot. And again, it could be all sorts of different shapes or sizes, or we could take a transect through that area. So here's my maybe forest again. A transect would be a line drawn any which way, that way or that way or that way, and figure out the population density along that line. Or we could do plots along a transect. So again, here's my forested area, here's my transect, and I'm going to look at these plots that go along the transect and figure out how many organisms are in there. Okay, so there are lots of different ways to do this, and usually scientists choose the method that's best for the organism that they're looking at and also for the habitat that they're investigating. So they have lots of different choices, from different shapes to a transect to plots along a transect, and they choose which one best fits what they want for the data. All right, so how do they actually then do this sample census? Once they've decided how they're going to set it up to do the sample census and figure out how many organisms are, they take the population density times the habitat area. So again, let me give you kind of a concrete example of this. Excuse me. We have, this is our plot maybe, and within that plot we found 7 bur oak trees. So I'm going to do those 1, 2, 3, 4, 5, 6, 7. Okay. And that was 1 acre in size. Our little plot that we made here is 1 acre. So we've got 7 oak trees per acre, but we know the whole area, remember this is part of a bigger forest here, so the whole area is actually 640 acres. So then we multiply those two. The 7 bur oak times the 640 acres equals the total amount of bur oaks in that whole area. And again, remember this is an estimate. Okay, if we went and did a true census of this and actually counted all the oak trees in that whole area, it probably wouldn't be 4,480 exactly, but it would be very close. So this is a quicker, probably easier way to get an idea of how many organisms are living in an area without having to count all the organisms in that area. So again, the estimated population is the density, so how many oak trees were in this first little plot, times the entire habitat area. All right, the last thing I want to talk about here is the fact that you don't necessarily just have to count organisms to get your population density. You can also count things that are indicative of how many organisms there are. For example, the more insects we have, the more egg masses we may have. Okay, so you could count egg masses as a sign of how many insects are out there. If trappers are bringing back furs from their various habitats where they're trapping from, that could be a way to estimate population size. Tracks, how many tracks do you find in an area? Nests, burrows, so the habitats themselves, or the little places where they find places to live within that habitat, are good examples of how many organisms there are. Feces, as kind of disgusting as it may seem, okay, finding different groups of organisms' feces and counting those up is an indicative number for how many organisms are actually out there. And antlers, lots of species shed their antlers, and that would tell us how many are out there as well. And this is just a small list. There are a lot of different things that you could look for to count that's not the actual organism, but still gives us a clue as to how many organisms are out there.